This program will help us learn about for loops. For loops are very handy when we know exactly how many times the loop needs to run or how many iterations it should have. One iteration is one trip through the loop. So when the code executes for one trip through the loop, that is one iteration. Well, we'll start writing a for loop with the word for. We'll have a variable here for int counter as integer equals 1 to 10. So this loop should run 10 times. And we're going to add the word woof to our list box 10 times. Int counter will be 1, then it will be 2, then 3, then 4, all the way up to 10. And there it is. Woof appears 10 times. The truth is, int counter actually does hit 11, but 11 isn't between 1 and 10, and it leaves the loop. How about 1 to 20? Woof appears 20 times. Kind of difficult to tell because it's the same word, but it does appear 20 times. And of course, a scroll bar appeared on our list box because we had more items there than the space vertically. Well, we're going to use the text box we had on that form to allow our users to determine the ending number. We'll declare a variable called int ending number, and we're going to get it out of the text box. We'll use integer.tryParse. You could also use try and catch just to make sure that there's actually a number inside the text box. So we'll use txtEndingNumber.text, that's our string, and then int ending number is where we want to place the integer value out of there. If there isn't a number, we're going to display a message box telling users that they need to enter a number. If there is a number, we're in good shape. So we're going to slide this loop inside that part of the try parse, and we'll use int ending number as our stopping value. We have a start value and an ending value. We're going to start at 1 and end wherever the user tells us to end. Well, end with 8, and there's 8 woofs. We can also display our counter variable. So now we'll add int counter, and you will actually see what int counter is every iteration of the loop. So if we start at 1 and end with 10, there it is. 1 through 10. What if we end with 21? Well, there we go, from 1 to 21. But notice that we didn't clear out the list box, so one list of numbers went right into another. So we'll go ahead and put the code in to clear the list box every time that we click on this button. Our ending number is 200. Doesn't take very long to place them in the list box. There they are. Now we'll end with 17. And again, we're displaying our counter variable. You don't have to start with the number 1. You could start with any integer since we declared int counter as an integer. So here we'll start with 14. We'll choose to end at 20. And there they are, 14 through 20. If you type in a lower number, such as 11, nothing happens because 11, to go from 14 to 11, you don't get anything to happen. So the loop does not execute at all. We'll set this back to 1 so it will work properly. The default for loops is to count by 1 or to step by 1. And almost all the time, that's what we want. But what if you would like to count by 2 or step by 2? It's like going up the stairs 2 at a time. We're going to copy and paste the code from counting by 1. We never need to tell a loop to count by +1. That is the default. But if we want the step to be up by 2, then we'll tell it to step 2. And it will be step +2. You do not need to write the positive sign. It knows that that number is +2. So now we start with 1 and go to 24. Of course, 23 is between 1 and 24, but 25 isn't, and that's why you didn't see that number. If we start with 0 and go through 16, there they are, stepping by 2. In fact, stepping by +2. Well, what if you'd like to count backwards by -1? That's also possible. We'll again use basically the same code we had from our first attempt at a for loop, and now our step will be -1. However, we're going to need to reverse our larger and smaller values. So we'll use int ending number first, and we'll go to 1. So I guess ending number is not exactly accurate, but we'll type in 10. That's actually where we're going to start and count backwards, because the step is backwards 1, or negative 1. There we go from 20. You can actually declare your variables in a for loop to be doubles if you would like and take decimal steps. It just doesn't happen very often. Now we have int counter declared in the loop. It says for int counter as integer. If I try to refer to int counter outside of the loop, there's going to be a problem. In fact, it's also declared inside of an if. So outside here in the sub, it doesn't know what int counter is because int counter was declared just for the loop and in fact just for the if. If we want it to be available for the entire sub, we can declare this variable before we use it in a loop. Then we can access it after the loop. Maybe we want to know how far that the number got if we decide to end a loop early, which I haven't shown you in this program, but it is possible. Now you notice that everything's okay. No red squiggles because int counter is available to the entire sub. It's really your option if you want to declare the variable before using it in the loop. Very often we can declare it just for the loop. We should also provide documentation anytime we use a loop. Anytime we use an if, we should declare documentation, which of course I didn't do on that if. But the job of this loop is to display from 1 to whatever the desired number was from the users. In this one, we're going to display from 0 to the desired number, counting or stepping by 2. But yes, it's a good practice whenever you use a loop to have documentation to explain what the purpose of the loop is, or describing what the loop is about to do. This loop was counting backwards from a desired number to 1. Now we'll look at how we can sum the numbers inside of a list box using a for loop. Let's put 6 numbers in there, 1, 2, 3, 4, 5, 6. They could be any numbers you would like. We're going to have to declare a variable to keep track of the sum. So we'll call it int sum as integer, because we do have all integers inside our list box at this time. I'll initialize it at 0. And it's going to contain the sum of all the values that are in the list box. And we'll use a for loop to traverse, that's another programming word, to go through all the values in the list box. We're going to start with an index of 0, 1, 2, 3, 4, 5. Notice that the length of the list is 6, but the last index is 5. We've discussed this before. So we're going to go from 0 to the items.count minus 1. Because the index of the first value is at index 0, and the last is at the index of count minus 1. Well, we're going to get whatever the item is, and we're going to use items and in parentheses int x. You see here it gets or sets, and we want to get the item at the specific index in the collection. And we want to get the item at index 0, and then index 1, and then index 2, all the way to the last index that is possible, which will always be the count of the items minus 1. Once that's all done, we're going to display the sum inside a message box. It's in the variable int sum, and we'll display it. Let's give it a shot. And the sum is 21. That's exactly what the sum of those numbers is. Int sum is 1, then 3, then 6, then 10, then 15, then 21. Another thing we're going to check out is having nested loops, loops inside of loops. So we'll take our values that we had inside the list box out, and now we're inside a nested loop, a for loop inside another for loop. We will want to clear out the list box before we run this sub, just like we did in several of the other ones. We'll declare an outer loop, and I'll say for int x. We very often use x, y, I, j, as our counter variables. We'll go from 1 to 12, and we'll have an inner loop. We'll call it for int y as integer equals 1 to 12. And then we're going to display the values of x and y inside our list box. So we'll have items.add, and we'll have to put a string in here. We'll say that x is, and then we'll display the value of int x. And notice that ampersand is in the parentheses, in quotation marks. We'll say y is, and the value of int y. The outer loop starts first. Int x will be 1, and then int y will be 1, and then 2, and then 3, and then 4, and then 5, and then 6, all the way through 12. When it's done, then int x will turn into 2, and then int y will start all over at 1 to 2 to 3 to 4, all the way to 12, and then int x will become 3. You'll see that happen here. Notice that int x starts at 1, and then the y loop runs all the way through 12, and then x bumps up to 2, and y iterates all the way through to 12. And then x goes up to 3. This goes on all the way until x is 12, and y takes its last trips all the way through 12. There's 144 lines inside here. The outer loop runs 12 times. The inner loop runs 12 times. 12 times 12 is 144. Well, we could also do some math with these numbers. Let's display the values of x times y. We'll have another 144 lines displayed in our list box. First you see multiples of 1, then of 2, then of 3, then of 4, then of 5. It goes all the way through the multiples of 12. We can also make a multi-column list box. So we'll click on the list box, go to the multi-column property. By default it's false, but we'll make it true. Now the scroll bar will not show up on the side, but rather on the bottom. When it runs out of room on the bottom, it will simply go to the next column. And this looks pretty neat. I already knew that on the size of this list box I could display 12 items, and then it would run out of space and go to the next column.